Zach, appreciate you taking the time today.
Well, thanks so much for having me.
Fantastic. Well, maybe you could start here by giving listeners a little whirlwind tour of your journey to senior editor for business and technology at The Week, and of course, a longstanding contributor to the New York Times.
Sure. Happy to. I guess, I got interested in journalism, in particular sports journalism, when I went to Syracuse University in New York, and it's a big journalism school. They have a long history and a great tradition there of student-led journalism. So. No, I always loved sports. I played growing up. I was a fan of sports. I was never as good as I wanted to be.
None of us are.
Yeah, but so it always kind of partly frustrated me, but also motivated me to try and stay involved as much as I could, so just kind of pairing my desire to kind of stay within arm's reach of athletics with a passion for writing. It seemed like a natural fit to be a sports journalist, and so I did that for really 6 or 7 years. I got hooked up with the New York Times pretty early out of college, and I was covering mostly local New York sports teams, the Jets and the Giants and the Knicks and all those other struggling franchises that are now, struggling to win games these days outside of the Yankees. So I was fortunate enough to be able to cover a lot of, the teams in and around New York City, and, as well as some of the major events for the Times over the years. I covered the Super Bowl. I've covered the World Series. Did a lot of college basketball, March Madness, and Final Fours, and I just loved not only being at events and talking to athletes, but there is a certain kind of storytelling aspect to sports that really always appealed to me, and so while I've kind of transitioned in the last couple of years to more of a business focus, and the nights and the weekends of sports writing did kind of take its toll, and I'm now more of a kind of a 9 to 5 type of job as an editor at The Week magazine. I still have a lot of interest in sports, and finding interesting sports stories or people to profile, and fortunately in that field, in sports, there's plenty of interesting characters, and so that's kind of where I'm at.
Yeah, so many great storylines in sports, and we'll definitely circle back to that side of things. But I'd like to dive into your fantastic book, The Performance Cortex. What was the impetus for you in writing that book?
Yeah. So as I'm talking about Yankees and Mets and things like that, it's really, and had been most of my focus for most of my career, is kind of focusing on these professional teams and getting to talk to athletes, but I was always interested in what it is that makes them who they are, what makes them great, because it was always such a struggle for me, right? And I knew I didn't have the genetic gifts that some of these athletes do.
Yeah,
but
such a huge factor.
It's a huge factor, but I also felt like there may be something else kind of missing, and I guess that sort of tacitly was probing me to investigate further. I never really put two and two together until I got started on this book, and which got me on this path to understanding, or trying to understand the role that the brain plays in elite and skilled movement. And so the way that this came about for me was really completely, serendipitous. My wife saw a little blurb in one of my Columbia alumni magazines about just a little profile of a startup at a Columbia University of these two neuroscientists in one of their labs that was interested in studying the brain and the way that the brain performs for baseball hitters. And so they were kind of working with the Columbia baseball team, trying to use some neuroscience equipment. In particular, they were using the EEG, and tracking, the neural correlates of a decision to swing or not swing at a pitch. And when I tracked up with them, this was around 2015, I believe. That's really, they were just it was very rudimentary. They had a simulation of a little ball coming toward a hitter from a hitter's vantage point. And it moved as quickly as a pitch would from a major league pitcher. And with that simulation, with a keyboard, all you had to push whether you decide whether you wanted to swing or not swing at this pitch, depending on whether it looked like a strike or not. And with that simulation, they were able to use the EEG to track when exactly that decision was made, down to the millisecond, right? And
it's incredible because it's obviously coming in so fast, and these days faster than ever, with so many pitchers throwing over 100 miles an hour, and to be able to see when these decisions are actually made, because it's not what we think it is it?
Well, that's right, and what they were able to do was, we've always been able to know when a hitter decides to swing at a pitch, right? Because he swings, I mean, there's a physical movement that goes along with that decision. But what these guys were able to do with their neuroscience equipment was they were able to see when that decision to not swing was made, because it's still a decision. It's still an activation of neurons inside the brain that's happening, in real time. But that decision was never, it never had that motor output. It never had that physical swing associated with it. And so teams never knew, when exactly that decision was being made. And it turns out that there are vast differences, even among great hitters, in terms of the timing and the accuracy about those decisions. And so, these two guys, Jason Schonbrun and Jordan Maraskin, had kind of tapped into a little bit of that in Columbia when I kind of discovered them, and I was able to follow them for the next few years as they realized that they could bring that data could be valuable to Major League Baseball teams. So I sort of followed them on their path to bring that information to Major League teams, what teams were able to do with it, and so my book kind of unfolded from there as partly a narrative around their work and what they're doing and why, but also to me it just became an opportunity to explore how we move, and the way that the muscles are often given most of the credit for our movements, but in reality, it's our brain that is really responsible for our skill. And so, I visited neuroscience labs all around the world, talking to the researchers that are probing what's exactly going on here, and I tried to get as much as I could in a readable, digestible book. Coming from me, and I've never taken a neuroscience class in my life. The furthest I got in science was AP biology in high school, so I was learning, along the
way, right?
Yeah, and so I wanted to make it obviously a readable, a digestible book, but also fairly informative for people who have those same questions.
And Zach, what were some of the biggest surprises as you were going around the various labs and meeting these leading world experts in neuroscience? What were some of the things that really stood out to you, whether it was from the information that you were gathering from these experts, or even just from your experiences of being in the labs?
I mean, to me, it was all a surprise. Basically, I know, like I said, I really didn't have much background in any of this stuff before I got started on this. And, I bought a textbook, a Principles of Neuroscience textbook. It weighed 10 pounds. It was 1,700 pages. It just sat on my desk for 2 years, and I would, kind of like I was scared to even open it at first, but actually the more I felt comfortable and was talking to people, the more interesting it became to dive into that stuff. But I think the big takeaway for me was actually how little we still know about the brain in particular and its relationship to our movement. The motor cortex, which is the primary seat of voluntary movement in our brain, that was discovered, quote unquote, discovered in 1870, right? By these two Germans working on, they were doing experiments on live dogs, and pretty gruesome stuff back in those days. But so that that idea that there's an area of our brain that's kind of responsible for the vast majority of our voluntary movement. That's been around. We've known that for over a century, almost a century and a half now. But there's still so much we don't know about what happens from that little patch in our brain, down to the muscles and the precision and the intricacy of the way that we move on a daily basis. And the best way to kind of underline this is look at where we are today in artificial intelligence and robotics. All right, we have the smartest minds in the world working on these problems and trying to figure out and create robots, and we're very good at the computational aspects of robotics. We have robots that can beat us in Jeopardy, beat us in chess, drive our cars, answer our phones, and finish our emails, and so on. But designing a robot that can consistently crack open a can of Coke, it's not really it's not there yet. We're not there yet, and we're getting better, but that problem of movement remains a huge hurdle for a lot of these great researchers. And so as I talk to them, I certainly learned a lot, and we do know a lot about what it takes to be skilled, and why practice works the way it does, and things like that. But there's still a lot that we have to still a long way we have to go to really understand what makes Stephen Curry so good at what he does, right? Because you look at him, he's 6'3". Yeah, but you'd see him walking down the street, and you wouldn't necessarily, if you didn't know who he was, you wouldn't think twice. You wouldn't think he's an NBA superstar. And so, what is it that enables him to be so skilled and be so good? It goes way beyond the muscles and the tendons and the ligaments and the reaction times that he's able to manifest from his body. It has to do with his brain, and so understanding a guy like him we're a long way.
Yeah, I mean, it's interesting you mentioned complicated problems like even surgery or flying a plane, or these complicated questions that are a series of ones and zeros, and computers can effectively drive cars and do all these things now. But when we get into these complex problems, like even though we might not think opening a can of soda is a complex problem, but it apparently is. Those are when it's difficult, isn't it, to just compute those? So it's a fascinating area, and in following the researchers around baseball, if we look at some of the things they were uncovering around when to hit, when not to hit, what were some of the aha moments for them that they knew they were on the right track with some of the data they were gathering in terms of actually having some actionable data that teams would be interested in?
Yeah, so Jason and Jordan started with the Columbia baseball team, and so they had this computer simulation. They were able to put the EEG cap on these hitters, have them sit in front of a screen. They tapped to swing when they wanted to swing, and they didn't do anything when they didn't like the pitch that was coming in. They were they could see whether it was a fastball, curveball, or a slider, and so on. And yeah, they with the EEG recordings, they figured out that there were certain players, certain hitters on the team that were faster and more accurate with their decision making than others. And the coaches would say, well, it actually makes sense because this guy is one of our best hitters, or this guy happens to have the best eye on the team. And so that kind of was the first, sort of eureka moment for Jason and Jordan that, okay, what's happening with their decision making does actually correlate to on-field success. And then, the more that they talked to coaches and the more that they worked with other players at other colleges around the country, the more that kind of that stuff it continued to multiply. I remember they were telling me about one of the teams they were working with at Bradley University, and they did the same sort of testing, and so they presented the coaches with a list of all the data of the players that were reacting or were their decisions were happening faster, at the times that their decisions were happening. And the coaches were like, oh, they pointed to a guy kind of at the bottom of the list. He was reacting more slowly, and that makes sense because we've been trying to figure out this guy has he's a great athlete. He's got a beautiful swing. And we just couldn't figure out why it wasn't translating on the field. And so looking at this, the EEG and the reaction times of the decisions, it helped them understand why things weren't necessarily working for this guy. And then the coaches could then go in various directions to try and solve that problem or to help this player out. Maybe it's throwing him more curveballs or various there's certain like occlusion tests that you can do, hiding the baseball in different ways to train a guy to improve his decision making. But just having that knowledge that they didn't have before, that they were looking at his swing and saw how beautiful a swing he had, but where he was missing was it was happening underneath the helmet. And so that was kind of the first giveaway for Jason and Jordan and their company, which is called DeCervo, that they could provide information to teams that they didn't have access to before. All the baseball statistics from hitting up until this point had been post hoc. It had been after the swing. It had been all the on base percentages and the exit velocities and all the statistics that Moneyball brought. Everything happened after that pitch was either caught by the catcher as a ball or was hit or swung at by the hitter. But there's a lot that happens in those 0.4 of a second in between the pitcher's release and the ball crossing home plate. And what that information can tell you can be very useful for scouting and can potentially be useful for training as well.
It is a fascinating area in terms of human performance, athletic performance. Last year I was at the Leaders in Performance conference, which brings together all the major sports and the performance staffs and executives, and around the whole room, the brain was the area, the next frontier of performance to be mined, to be able to get these marginal gains of performance. And so it is fascinating, as you mentioned there, because you can watch someone swing, but being able to have an insight to what's happening as the pitch is being thrown or before the pitch is being thrown is really interesting. And when we cross over to other sports, I think of a sport like tennis. You watch Roger Federer return a serve that's coming at him at 140 kilometers an hour. It's almost impossible to see the ball at that speed. I mean, can you talk a bit about the patterns and some of these recognition that the brain's getting into to be able to differentiate what's going on in terms of where the serve might be hit, etc.?
Yeah, I mean, we often talk about reaction time when it comes to fast-moving sports like hitting in tennis or hockey or things like that. But the reality is that reaction time almost has nothing to do with it. Our reaction time, really across all humans, is roughly the same. My reaction time doesn't vary that differently from someone like Mike Trout, and so maybe he's a little bit faster than me, but not too much. And so what is it that, and this goes back to it, there was an old experiment that I wrote about in the book that they actually brought Babe Ruth into Columbia to test him out as trying to figure out
Amazing.
And so they did all these studies on reaction time and at the time, they thought, oh, this guy he has got much better reaction time than everybody else based on their testing and their results. That's what the conclusion that they drew, and I think that kind of perpetuated a long way. I mean, it makes sense, but in reality, in the years since, we figured out that reaction time really doesn't vary too much from person to person. So what is it? What is it that separates these great reactors in their sports? And the difference really is their ability to predict what's happening. Their skills of prediction is much better, and that just comes from years and years of experience and practice in picking up on the little cues that their opponents are giving away, that are not just subtle, but maybe even undetectable by someone like you or me standing in the batter's box at the same time. And so it's really it's really interesting. There was a study that I wrote about in my book about free throw shooters. They did this in Rome, and they took video of a guy shooting a free throw, and they zoomed in all the way very close to the fingertips as soon as the ball is being released. And so they showed this clip, and so they didn't show anything about the ball going in or the ball not going in, but they just zoomed into the fingertips as the ball is being released. They showed this clip to coaches and ex-players and journalists and fans who watch basketball very closely, and they asked them, based on the video, did the ball go in or did it go out? And so, as it turns out, then they showed the same clip to current players that were currently playing professionally in Rome. It turns out that the players that were currently playing were far and away more accurate in telling whether or not the ball went in or not, just based on looking at the fingertips. And they were more accurate even than coaches who spend their entire days doing
watching basketball players.
So, there's something about active experience, active expertise that might just be a little bit different, even than an ex-player or a coach. There's something that these athletes are picking up perceptually that helps them in whatever way is necessary, and gives them the advantage that they need to succeed in their sport. And I'll give you another example of the way that prediction works in particular in baseball. You might remember, about 15 years ago, there was a celebrity softball game, kind of for charity and whatnot.
Yep.
So they had Jenny Finch, the great Olympic softball pitcher, facing some of the baseball's best hitters, Barry Bonds and Albert Pujols and Brian Giles, and these were the top sluggers in the game at the time. And now Finch, she throws hard. She throws about 95 miles an hour, but that's not like nothing that these guys face every day. And yet she gets up there and she just blows the ball by them. They were so dumbfounded. Some of them couldn't even get the bat off of their shoulders. And now, why was that? The reason is because she was throwing underhanded. And these guys had spent their entire lives and entire careers focusing on the pitch overhand, where that ball is coming out of the pitcher's hand, that exact moment at that exact time and place. And they were so ingrained. They're so used to watching for that and picking up on those cues and predicting and using those cues to predict where the ball is going to go. That the change to go underhand, it made them amateurs again.
It's incredible.
And, it's just an example of the way, again, that this has nothing to do with vision. It has nothing to do with reaction time. It's your brain's ability to predict. To use what it has around its memory and also its perceptual mechanisms to predict what's going to happen.
Yeah, that's really something, isn't it? To see that. I remember watching the highlights of that. It was just incredible to see, as you mentioned, the best of the best in the game, and just struggling to keep up. And when we look at technology, so much promise in technology and monitoring across all sports and different domains, whether we're talking recovery or outputs, and obviously the brain as well. In researching the book and the information that you were able to compile, obviously a lot of promises are made around what we can do with a lot of this information. What did you uncover around various apps or various devices that were actually coming up with some substantial potential, and then some of the ones that maybe not so much?
Yeah, I tried to kind of focus. I didn't want to get too far into the into the brain gaming and the whatever it's called, the cognitive gaming and things like there are various words for it. And it's definitely a growing field for sure. The reason that I liked DeCervo and the reason I followed them was that and made them the focus of the book, is that their premise, at least when they start, and they kind of have changed their business model a little bit, and that also came into the story. It's very tough. Sports science it's a tough business. It really is.
Yeah.
And teams want certain things, and they want things to be easy and marketable and packaged right. And so, a couple of neuroscientists trying to get into this industry was, I think it was eye-opening for them, and fun for me to chronicle as well. But the reason that I liked them initially was that they weren't necessarily offering performance benefits, right? They were saying we have kind of like we're offering like a radar gun, right? We're offering this is for the brain. It's the brain. Yeah, it's measuring how quickly your brain signals are firing, and you can do with it what you want. You can use that information however you want. We're not promising that your hitters are going to get better. We're not necessarily promising that you're going to be able to scout the next Mike Trout because of this information. But we know that you're hungry for data. And this is data that's never been accessed before, and we can help you access it. And so I kind of liked that simplicity and the the lack of the promise. Anytime that companies are promising a lot, especially when it comes to performance, kind of me as a journalist, my antennas tend to go up and make me kind of curious and really what's actually happening here, and how is this actually happening, and so I did kind of like that they weren't promising much, but they're not the only they're the only company that I know of that's using EEG, and they're using their background as they are neuroscientists. I mean they're both PhDs. So they're the only ones that I know of that are using that neuroscience background with neuroimaging equipment and bringing that onto the sports field. Maybe that's changed in recent months, but as far as I know, they're the only ones. There are some other companies that are certainly interested in trying to harness trying to understand the brain and pitching themselves as neural or perceptual and cognitive companies, but I'm not that familiar with them enough to necessarily endorse any or critique any. I don't have the familiarity with that, but it's definitely, you're right. I mean, it's a growing field. Teams are certainly interested in it, and I think it absolutely has to be a growing field. I think if you're an executive or somebody working for a sports team and you're not looking in this direction to try and understand the way that the brain is used by your athlete, I think you're missing out. I think it's it's absolutely the future. Our understanding, our knowledge about it is only going to grow. There might be mistakes made, along the way, but where we are today is so far from where we need to be in terms of our understanding of what are effective uses of practice. Why do we do batting practice? Just these questions that bother me.
Yeah, batting practice at 65 miles an hour only to step into the batter's box against 98.
There's just things that we still do based on, I guess, just habit and tradition, and in sports, and it flummoxes me. I don't understand it, and so anything that'll ask some of these questions or test some of these conventions, I think is important.
Especially when you talk about batting practice in a sport where they play almost every single day for 180 days, you'd think that. Like you said, tradition reigns pretty strong, and then these things are kept in the system. And Zach, throughout writing the book, when we think about take-home messages that translate, whether you're an athlete, whether you're a coach, practitioner, performing in your job, what were some things around the brain that resonated with you? There, some real take-home messages.
To me, it was an entirely new way of looking at almost everything that I've known about sports and about athleticism. and I know that sounds like grandiose and silly, but it's really true. I mean, you know, I think as sports fans and athletes, growing up, we're sort of conditioned to think about the physical aspects of performance. We are enamored with with the super tall guys and the genetic gifts of some of how fast they run, how high they jump, and how hard they throw. But that's just such a small piece of what make great athletes really great, right? When LeBron James is running down the court, and again, he's as fast as they come, he jumps as high as they can jump. But when he's dribbling down the court and he makes a perfect behind the pack pass to an open teammate in a fast break, we don't necessarily think anything of it these days because he makes it look so easy. He does it so often. But the computations that are required for him to be able to not just predict where his teammate's going to be, but also to sort of sense where his opponents are going to be while running down the court and also dribbling at the same time. It's mind-boggling, what these guys are able to do. And again, it just, it's not about, he didn't have to lift a lot of weights in order to be able to do that. He didn't have to jump straight up in the air and do squats in order to be able to make those passes. It's something else. It's something that he's practiced or worked on, playing the game of basketball that makes him a genius. It really does. And that, is one of the things that I argue in this book is that, these super skilled athletes are a form of genius. They are using their brains, maybe not in a way that we necessarily think about intellect and computation and problem solving, but it is. I remember talking to one of the neuroscientists that I wrote a lot about, John Krakauer from Johns Hopkins, and he's one of the great thinkers of our generation, and he just loves athletes. He's fascinated by them. He loves Steph Curry, endlessly curious about what makes Steph Curry so good. And we were talking about skill and athletics and why it seems that sports writers, he was teasing me a little bit about being a sports writer, and he's like, you sports writers, you're always obsessed with the body and the physical physical traits of these guys, and you're writing about how fast they throw, how fast they run, and how high they jump, and all. And it's just not. It just means nothing. And he's like, it's like saying that somebody who speaks French really well is because he has a very dexterous tongue. It's just the wrong place to assign the credit. And
interesting.
A light bulb went off, to me, and maybe I'm the only one, but I think he's absolutely right. There's so much more that goes into skill and being a great athlete than the motor outputs per se. It's what's the brain is doing to produce that movement that is the key for these guys. And
absolutely. Last season had Dr. John Sullivan, a neuroscientist as well, works in professional sports. He wrote a great book called "The Brain Always Wins," and I think that's a good, good title for the themes of what you talk about in your book. And of course, so many great studies that you talk about, and great stories as well. And of course, I think I've heard a few sports writers talk about how you're a writer first and a sports writer second. And today, if we shift gears here a little bit, obviously, doctors, nutritionists, strength coaches, everybody's writing online now. What makes a great writer?
Oh, geez. I mean, I don't know. I'm certainly, not the one to be trying to summarize any of that.
Well, I mean, in your experience, and obviously the levels that you've achieved, and obviously a lot of wisdom to share. So.
Listen, I mean, I think for me as a journalist, I have certainly a healthy curiosity about things, and I've always wanted to know, why things are. I guess that's kind of the question that this thing that sort of nags at me. And even as I'm watching sports, I'm not that interested in covering sports in that sort of the day-to-day, who wins, who lost. But I really have always wanted to know, what's happening to make these make these athletes so great, and just some of those bigger questions that maybe seem unanswerable, but that they always kick around in my mind a little bit. So, I guess curiosity is certainly one thing, and just observation is always a powerful one. Whenever I speak to classes and younger writers and students, I'm always talking to them about looking around and keeping your eyes open. It's so easy to get most of your feel like you're getting most of your stories or trying to cover things via Twitter today, and
sure.
and it certainly makes it easier to find some things, but I think that's that can also be a dangerous habit. Spending too much time in a social media feed. I think it's important to get out and observe as much as possible, and just try and see things in a different perspective, and
absolutely.
As far as how that translates into writing, I guess it's I always wanted to write a book, but I didn't necessarily think that I was going to do one at the time that I did it. But sometimes one of these stories kind of hits you, and you can't let it go. And for me, that's what this one was. I would say to anybody who's interested in following in the footsteps and wants to write a book, I'm all for it. I just would hesitate. You got to make sure that you're ready to spend like 3 or 4 years.
Yeah.
You can't do these things that you're ready to ditch after a month or so, because it's a lot of work, and it's a relationship that you have to be willing to get into. Because otherwise it's going to be torturous.
I mean, the storytelling aspect is fascinating on a number of fronts. I mean, when we look at just the research around it, as you talk about the brain, of just storytelling from generation to generation, and from an evolutionary perspective of being able to pass on information and having people remember it in those settings is so important. And our sports psych at Canada Basketball, Dr. Peter Jensen, always talks about how 90% of the decisions that we make are based on emotion. And of course, any good marketer knows that telling a good story is how people triggers emotion, and then people respond to that. And as a sports writer, I imagine that's a big part of the storytelling in athletes, of that the story behind the athletes, and how you can really convey messages through those stories. And so I think that's a great part with your book as well, and just as a journalist or writer, how those stories can really connect with people and influence. As a practitioner myself, and whether people are strength coaches or doctors, we sometimes try to give the facts to people to influence decision making, and of course there's a place for education, but being able to use stories to convey some of the things we're trying to get across is a pretty powerful tool, isn't it?
Absolutely. I mean, it is, and as I try to go about this book in particular, these scientists that I focused on, maybe were not the award-winning scientists. They're certainly brilliant, and they're leaders of their field, but they weren't the preeminent Nobel laureates that I could have chosen to tell this story. But I wanted to find people that I thought were interesting, that I thought could describe things and also be relatable to the readers, in ways that brought it a little bit more to life. I tried not to make it as, and maybe some people will say it was dry, but I tried not to make it as dry as I guess a book about neuroscience could have been, and I think that's partly, or at least mostly, because of the characters that were involved, and these are scientists that are asking pretty deep and fundamental questions, but I thought they were great, just great people to spend time with, for me, and I hope for the readers as well.
Fantastic. Well, it is definitely a terrific book, and Zach, where can people stay connected with you and pick up a copy of the book?
So you can pick up a copy anywhere. It's really Amazon, I guess.
Amazon these days, right? Yeah.
I hesitate to say Amazon, but it is it's hard to beat Amazon with next day delivery. But
for sure.
So But otherwise, it's in most major bookstores. And yeah, so my Twitter is just at Z Schonbrun. Yeah, so I don't tweet as much as maybe I should these days, but you can definitely you can reach out to me if you have any questions. I'm happy to help.